Hello everyone, now I will show you the demo of AlloyMC. Note that since Project MC is not supported on our current operating system, the Mac OS, I'll only show you the usage and the final results of AlloyMC in this video. You can test Project MC on your Linux machine, and the whole procedure and the format of its final output is just similar to AlloyMC. So for the first step, we need to run the jar file which we downloaded from the GitHub repository in terminal. Note that the JDK version should be at least Java 9. Then the user interface will show up automatically. In the right log panel, we can show a warning that Project MC model counter does not work on this Mac platform. This is okay since we can still use AlloyMC as a counter. Now we can open the example Alloy model and test it. In the example Alloy model, there are 5 count commands in total. The first one is a default one without any expect clauses. The second one has a negative expected value, which will be ignored during its execution. The third one has an expected value in the form of A times B to C, and its default relational operator is equals, which means the user wants to check if the exact model count is equal to the count he gives. The south one has an extremely large expected value, which will exceed normal integer range. Our AlloyMC will handle it very well and gives us the correct results. The last one uses a larger than and equal to operator in the expect clause with a positive expected value. Other relational operators supported include equals, not equals, smaller than, larger than, and smaller than and equal to. In the options menu, we can select the symmetry breaking degree and the counter we want to use. Now we'll just use the default ones, the symmetry breaking degree of 20 and the AlloyMC counter. In the execute menu, we can run each command respectively or run them together. Note that since the second command has a negative expected value, its expect clause will just be ignored during the execution, so it is just the same as the first default count command. Now let me run these commands one by one. Now let me run them together. We can see the model counting results in the right log panel. We can take a look at a specific command's output. Say the last command. The model counting results include the parameters of the set formula, the time used by CNF set solver, the exact model count and the specific symmetry breaking degree, a hyperlink to the full counting results, and the time used by the counter. When we press the hyperlink, the full model counting results will be shown in a text window. Sometimes, the execution time of counting may be too long for the users. They can also choose to stop the model counting process and run some other commands. So now we add a count command, count cyclic for 50. This new command will take a much longer time than the default command count cyclic for 5. When we press execute, we can see that it takes a little bit longer to generate the CNF, and for the counting process, it will take even longer time. So the users can now press the stop button, and the model counting process will then be stopped. The users can now run some other commands he wants to run. That's all the content of the demo. Thank you for watching.